G'day folks. Well, it's been a busy morning and I got some surplus to deal with. I'll start with the stuff that I bought off a surplus dealer. I got a 9-inch grinder for $100. It's a Bosch GWS 25-230. Awesome grinders they are. A whole heap of wheels to go with it. Some of them are lightly used and a lot of them are new. Some new Flexovit ones. Grinding wheel. That's also from surplus dealer. He's got more coveralls and things for me. They're all lightly used, come back from an industrial cleaning service or industrial coverall supplier, something like that. New visor with some 2 spare lenses. Even those were $16 each when they were new. Paid $2.30 all up for all of this stuff. And that needs a new battery, but it's just a roadside safety lamp, highway safety lamp. Made in Australia by Highway Safety Developments Proprietary Limited in Brisbane. 4.7 volt batteries. So I just got to pop it open and change the battery or batteries. So that's good for $130. The MIG was free. Don't think it works, hasn't worked in a while, but I might be able to fix it. Monitors and stuff I just got from the scrapyard. I've got plenty of those BenQs, so I can always use spare parts. That one's got a scratched panel, so I've got another one inside which doesn't display signal, but the panel and everything in it's mint, so I could probably make one out of the two. And this has been parted out, but it'll be a good equipment autopsy. It's an Acer Aspire 5315, nothing too special. 1.7 gigahertz Celeron, half gig of RAM. Yeah, it'd be dirt cheap when they were new. So we'll do an equipment autopsy on this, probably tonight. Got enough bits of auto air conditioning stuff. I should be able to build a little system that runs off the China diesel. I'm going to set it up so I can run a little air conditioning system off this. Just belt drive the compressor. But that's another later on project. So there's that stuff to sort out and put away, and that to test. I've got a vintage pedestal fan or desk fan. Lenco Electrics. I think this worked. I plugged it in and it started moving, so that's good. It's just a bit stiff. And a fridge. Dirty, old, apparently it still worked. So give it a test run and give it a clean up if it passes. Yeah, it's very good. So this part of the video we're going to be looking at these two. I've got some truck battery cables for bridging 2 batteries for 24 volts. They're always handy. But yeah, we'll look at these two next. Alright, well I've given the fan a bit of a once over and a clean up. The bearings were a bit dry, so I've lubed them up with a bit of light oil. It turns a lot more freely now. Had the base off it, just to check out the electrics, make sure all the ground wires and everything are good, and they are. Switch is good. It's a very basic rotary contact switch. And I found something interesting when I was cleaning it. Bit of history. That engraving there says Ansett/ANA, Ansett being Ansett Airlines, a defunct air travel company. ANA must stand for, can't remember really, can't remember what that stands for, Australian National Airlines or something like that. And under its VEP 173-248, I'm guessing that's a asset number or something. I'm guessing this came out of an office or something like that for Ansett Airlines, and that's its asset number. Obviously there would have been a lot of surplus like this once the Ansett offices were liquidated, and maybe even earlier before Ansett folded they probably got rid of this, but yeah, quite interesting. At first I thought the grill was broken, but I figured it's the only way they're going to get the fan blade in there, so they just got this bar missing. So it is complete and unbroken. One of the blades is a bit rough, but yeah, it's not bad. Very similar design to the PYE or Pi fan that I've got in my bedroom at the moment. Roughly the same vintage too. I don't normally collect fans and things, but these things are just cool. It's super quiet, like literally silent, and yeah, just old school cool. They're good to complement a good air conditioner and blow a bit of the cold air around. So yeah, let's put the base back on it and plug it in. Actually, I'll leave the base off for now, just in case I have to fiddle with that toggle switch. Alright, let's see how we go. Much better. So I plugged it in at the scrapyard and it was barely trying to move. But now it's got properly lubricated bearing, it's pretty good. Is the oscillator going to work? No. I think the oscillator gear's stripped. Yeah. Okay, so the oscillator doesn't work. Doesn't matter, I'll just put it back to home position there. Yeah. Might be able to fix it. Might have just simply slipped down on a grub screw or something. Good. Now it's all grounded, so make sure these metal cased appliances, always make sure they're grounded and you're on an RCD. There are times when RCDs are handy. I'm not a big fan of them at all, but yeah, sometimes they do save your ass if something goes short to ground. So it's medium and low. Yeah, they all work. Speed's controlled via a little ballast in the base there by the looks of it, or a transformer, whatever that is. Looks like a transformer, but it's only got 3 wires coming out of it, so yeah, I'd say it's a transformer. It's got a bit of bowls to it at high speed. And off. Works. Good. Let's set that up somewhere. Good thing about this base is it also has the little hole and slot in it, so you can put a big broadhead screw in the wall and hang it on there. So you actually hang it off the wall, undo the locking screw here, tilt the head right back so it can hang off the wall and blow air down at you. You don't have to sit it on a table. So, very handy. I suppose I should give you the name anyway, Lenco Electrics, Australia. Yeah, Lenco Electrics, made in Hyatt, Victoria. Type 12 OA, 230, 240 volt only, 50 cycles, which is 50 hertz, and 40 watts of power. So it's only a 40 watt motor. Good. They can go in the keep pile. Let's look at this fridge next to make sure it works. Okay, let's look at this dirty little Matsushita or national brand bar fridge. Obviously it's been sitting around for a very long time without being used, and I think that's why they got rid of it. It's just filthy. But it's nothing a bit of scrubbing can't fix. It's been spray painted. Which was sort of the rage many years ago. A friend of mine, the guy who runs the scrapyard, used to be an auto body repairer, and he said back in the day when he was doing spray painting, he used to get people bringing fridges in all the time to get a spray job. And it looked pretty good apart from all the scratches and dents. The dirt's covering most of them right now. But yeah, apart from needing a lot of cleaning, I hope that's all it needs. It's an old R12 unit. It weighs 49 pounds. Yeah, Matsushita Electric, made in Japan. 240 volt, 50 hertz, 0.7 amps. So very, very low current. You'd just sit ticking away all year and you'd hardly notice it on your power bill. Compressor, yeah, Matsushita Electric R12, 1/16 horsepower. That's how small it is. And that rubber mount's collapsed. Yeah, its rubber mounts have collapsed. I might try and sneak some little rubber grommets underneath it. Just carefully lift it up and just chock them underneath, jam them under there. Because it's almost touching the metal base plate there to become a bit noisy at pressure. But I guess the first thing to do is to give it a test run. It hasn't been wet, so we'll just plug it in and see what happens. And see if the lights go out. Everything's grounded, so we're pretty safe. Still got that little fan running, that's quite happy doing what it's doing. Always give them a good run too, don't just do what I said before and just put it straight in the pile. Make sure it doesn't overheat, but that thing's still stone cold and it's been running for 15 minutes. That's a good motor. Yeah, like I said before, it needs a good clean. It smells like mank. Old mank. Never use sharp tools to remove ice from freezer. Yes, somebody at my work found out the hard way. We're using a chisel to remove ice from the lunchroom freezer. Whoops, went straight through the coil. You can find that video somewhere else on my channel. Oh well, lucky it was only one of those dirt cheap Chinese fridges. This thing here is probably 10 times older than those Chinese fridges when they die. I see them all the time. They're only a couple of years old and the compressor's dead or they've got no gas in them. And they use a flammable propane-based gas, so it's not as easy to recharge as you think. But I'm sure I could probably pump R134A in them and they'd be just fine. Just not worth the effort. Alright, power on. I hear a compressor. It's working. It's running anyway. It's not too loud. Good thing it's got a service valve on it too. I like that. Yeah, there's the ground wire there. That's alright. Looks a bit shabby though. It's all good. Table's grounded, I think. Yeah, there's an earth lead on it. The camera doesn't have autofocus, but I don't think I want autofocus, seeing how much trouble people have with it doing close-up videos. You can hear liquid coming through. Oh yeah, it's frozen. Yeah, it's already ice cold. Like below zero. It's freezing the pads on my fingers. Alright. Let you run for a bit. And then take it outside and clean it. Nothing but a coil cleaner won't get rid of. Most of that's just dust and dirt. Give it a cut and polish. Paint should come up alright. It's definitely been spray painted. There's white underneath it. Yeah. Well, let her run. I still get questions about how refrigerators work and things like that. I guess I'd better do a proper video one day. But I'll throw a little snippet of info in here and just try and explain quickly how the principle works. And basically these systems are always under pressure. You've always got pressurized refrigerant in here, which turns into liquid at the coldest point. And when the compressor starts, it starts sucking in liquid into the pump, compressing it out the discharge into the condenser coil at high temperature and high pressure. Like this coil's currently getting warm, quite warm. That discharge line would be about 110 degrees Fahrenheit or about 40 something degrees Celsius. So it condenses through this coil, where just in this case it's just pure radiation, pure convection to dissipate the heat to atmosphere. Some bigger ones have fans on them, or the coils under the front with a little fan on it. Air conditioners obviously have fans since they're ejecting so much heat. And it comes out through here. This contains desiccant. It's a dryer. It absorbs any moisture that might have been in the system when it was charged. It wouldn't be doing anything now apart from filtering any particles that might be in the coil, but this is mainly for when the system's first put into service. Now it's coming out through this little capillary tube, very fine spray or fine stream of liquid, solid stream. If it's making surging and hissing sounds, it means you're getting vapour coming through the liquid line. And it might be low on gas, or the compressor might be tired, it might not be making up head pressure. Yeah, so it's coming up here. It's bound to the side of the suction line too, the return. It'll go inside here, and what it works on is expansion. If you ever sprayed gas from a lighter refiller can, or even something like this, if I were to spray this on the table, the contents are probably about 25 degrees at the moment, but as the propellant inside evaporates, it gets cold, and it actually, you get it on your finger, you can feel it getting colder and colder as that evaporation occurs, and that's what this is doing. There is an injection point up in there somewhere where that tape is. That very fine capillary line suddenly opens up to this big coil here, which is connected to the low pressure suction side of the compressor. So naturally that spray of liquid is evaporating and boiling off as it goes through the coils. It's turning into vapour, and it's absorbing all the heat that's inside the cabinet. So it's taking the heat from inside, taking it back to the compressor, which is this line here. So that's nice and cold now. It's got return cold gases going through it, but no liquid. And it's going back into the shell of the compressor where the pump can pick that gas up again, compress it, Also taking some of the heat from the motor and pumping it back out to here for heat rejection. Without the condenser coil, it won't reject heat. It'll just sit there doing nothing and getting hotter and hotter and hotter and then eventually die. So that's why blocked condensers or obstructed condensers kill air conditioners and fridges. If you can't reject the heat stays in the system, it stops condensing liquid, pressure goes up, the compressor gets hotter and hotter and it dies. So keep them clean, don't put it hard against a wall or something like that. Most of these fridges these days have them built into the cabinet, like they're laminated to the steel cabinet, and they have plastic standoffs on the back of them so you can't put it hard against the wall. This one here should have those, but it doesn't. So yeah, if you were to put this hard against a wall, its efficiency would drop substantially. Unless it was a metal wall or something in which it could transfer heat through, but most of the time it's usually plaster or drywall, whatever you like to call it. So yeah, refrigeration's just taking heat from one place and putting it in another, using the compression and evaporation of a refrigerant, be it anything from old school CFCs to propane. A lot of the new Chinese fridges, as I mentioned, they run butane or ethane or some kind of flammable refrigerant. They've got flammability warnings all over the damn things. So the same sort of deal as I showed with the can of inox. As soon as you release from a high pressure side, which is inside the can, to a low pressure side, you get evaporation, and that's what those bubbles are. Because the propellant in this is so volatile, it's evaporating at this atmosphere, ambient temperature and atmosphere. Keep it cold enough at this atmosphere and it won't boil, but it'd probably be negative 50 degrees or something silly like that. So it's probably the best example. That or a can of lighter fluid. You spray it on something and it will get very cold very quickly as the gas suddenly goes from liquid state to vapor state and takes heat with it. So yeah, I hope that sort of explains things and lengthens this video, because I believe this fridge is working fine and just needs a clean. It's not surging. I can hear liquid flowing through the coil, but yeah, it's just iced up now. It's frozen. And that's what you want. That's the freezer. Alright, I'm going to clean it up first, then give it a really good run and give it the okay. I'm going to take it to work, I think. We need one for the engineering shop, just to keep our drinks in, particularly summertime. It's so hot in engineering. But that's what you get. Okay, well that's that one done. Came up pretty good. Only took about 20 minutes to clean it all. It smells fresh. I used food department approved coil cleaner. I should clean these rods though. But yeah, needs a little bit more of a wipe out after it dries, but overall that's pretty good. And the thermostat works. I think it just cycled off. Yeah, it's cycled off now because I set it down to low. That's working. Yeah, I'm quite happy with it. It's cleaned up pretty good. It's just a bit scratched. Door seal's good. Compressor charge and everything's more than adequate. Yeah, I did pull that off before I cleaned it. I got most of the electrics out of the way and just hosed the whole thing down. I'm just going to jam a rubber washer or something under there. I'll just split the washer and push it over it. Obviously I can't lift the compressor high enough without breaking something, but or to get it over, but yeah, I'll just lift it up carefully with a little pinch bar and slot a washer in underneath. Yeah, all good. Oh, thanks for watching.